All right, 14.7. Apply
This is the hard one.
double
Standard.
angle and half angle formulas. All right, double angle and half angle formulas. All right, starting with double angle.
Is this hard? Oh, this is the one you said was
Oh yeah,
hard.
this is the hard one.
All right, the sine of 2a is equal to 2 sine of a cosine of a. The cosine of 2a is equal to either 1 minus 2 sine squared of a, or it's equal to 2 cosine squared of a minus 1, or it's equal to cosine squared of a minus sine squared of a. And then do this to break them off. Tangent of 2a is equal to 2 tangent of a over 1 minus tangent squared of a. And then our half angles. We have the sine of a over 2 is equal to plus or minus the square root of 1 minus cosine of a over 2. Cosine of a over 2 is equal to plus or minus the square root of 1 plus the cosine of a over 2. And tangent of a over 2 has two options. It's either equal to 1 minus the cosine of a over the sine of a, or it's equal to sine of a over 1 plus the cosine of a.
So on the test, the next quiz we have, are we gonna be able to do those cheat sheet things?
Yep.
Can you slow just a little bit?
All right, over here, because these are plus and minus, okay, the signs of sine of a over 2 and cosine of a over 2 depend on the quadrant in which a over 2 lies.
Can you scroll like so we can see the very bottom of the sign? Yeah, thank you.
Hey Sarah, is my desk closer to the door than normal?
I sold them all because people were too close to each other.
Are we reading examples next?
Yeah, we're probably gonna do one, maybe two. I don't know.
Are these like long problems or you like
Or we might just have a quiz.
Really? I have a really quick question.
Don't sleep in my class.
And I think I already asked it like 2 seconds ago, but it like completely lost. Like I definitely asked 2 seconds ago, but are we gonna be able to use these formulas?
Yeah,
over
yes,
two? Okay, I know I asked that 2 seconds ago, but
Yes.
it really just left my brain.
That's the red-headedness.
All right, examples.
Almost done. Oh, can you just scroll up to the green one more? Thank you. I just need that.
All right, the cosine of 165 degrees.
Do I still need my unit circle?
Yes.
Do these
All right.
take up a lot of room?
Oh, there's
A decent amount, yeah.
okay.
It depends on if you're gonna write like all the way down or if you're gonna like write down and then come up and start to like stack it beside each other.
With the cute little arrows, I have so much fun drawing the arrow. I don't know why.
What number is this?
It's just an example, not a number.
No, exactly.
Just a little
All right.
bit of
So with this one, okay, 165 degrees is not something we know, correct?
Yes.
Correct.
Okay,
We have to do the thing.
but it is half of an angle that we do know.
65.
Okay.
Is it 120? 20?
No, this is half of an angle we know.
Then what is it?
Okay, if this is half of an angle, we need to multiply it by 2.
330.
330. Yeah.
Okay, 330. So this is the cosine of half of 330 degrees.
That is cool. I mean,
Why do we write it like that?
I thought that we had to divide them.
Huh.
Me too. I was like, there's no way.
like we don't know that. Like,
I looked at it and I was like, uh-oh.
So then,
Okay, so now we're using this formula for the half angle here for cosine. So it is going to be,
So you knew it was a half angle formula because it's I figured out it was half of the angle. But we knew. Never mind. I just made myself seem incredibly stupid.
yes.
what is
Huh?
A? Is A the
We'll
angle
get there in
of
just a
30?
second. Okay, first and foremost, I want to decide if I'm using the positive one or the negative one. Okay? So to do that, I'm looking at A over 2. Okay, don't get confused. I'm not looking at this 330. I am looking at 165. So this is going to decide positive or negative over here. Okay, so what quadrant does 165 lie in?
2.
Okay, 2, meaning my cosine values are what?
Negative.
So it's going to be negative square root of 1 plus the cosine of 330 over 2.
is the 2, okay, this might not matter, but just for the sake of the fact that I never know what I'm doing,
It won't matter.
does the 2 go under the square root, or does it, okay.
Okay,
Yes.
I do have a question. So the first time you figure out A over 2, you use the 165. The second time you use the number you got. I don't know.
The second time it's not A over 2 anymore. This is your new value.
Why is this?
This is now A.
Oh, that makes sense.
Are you
Okay,
sure?
this value here is A over 2.
Because it's like the.
So it's 1 times
I
square
got
root
it.
of 2.
Thank you very much.
All right, so now what I'm doing is I'm going to figure out what the cosine of 330 is.
3 over 2.
Root 3 over 2.
Wait, I'm confused. That's the tangent, I mean that's the cosine, I'm sorry, okay, we're good.
So now you got multiply 2 by everything?
No. What do you mean? To get a common denominator?
What do
Is
you-
that what you're asking?
Well, I'm to get rid of the 2 on the bottom.
No, I can't do that. Not yet. So this is now going to become negative 2 plus root 3 over 2, all over 2,
Wait, why did you get a 2? Oh,
because I need to have a common denominator to add them together.
so did you literally just,
Ariel doesn't understand. I don't either.
okay, why did you move the 2 that's under the square root of 3? Oh, never mind. You
Common
just put it underneath
denominator.
the whole thing, okay.
if you have 1, and I know this won't happen, but if it's 1 plus the square root of 3 over 4, you just have 4. Like, you could just do 4, right? Like, it doesn't change anything. Like, 1 over 1, okay. If you have
You could rewrite that as 4 over 4.
Yes, and you don't have to multiply it, because, do you have to multiply it? Do you understand what I'm
Well, in technicality, you did multiply. That's how you got 4 over 4. If I'm understanding what you're saying, which I think I am, but I'm not sure.
When you multiply, does it change anything else but the 1?
No, unless they had different denominators to begin with.
Okay. I get it.
Like if one was like a 3 and one was a 2, you're going to have to make both of them have a common denominator of 6.
Yes.
But in this case, since it's just a 1, you don't need to change that one.
It makes sense to me now, I guess.
Okay, so this is where it can get a little confusing if you don't remember your basic rules, okay? That is what this means.
Yes,
This
divided by two.
Yeah.
means this, okay? Dividing by 2 is the same as multiplying by 1/2.
So if you're dividing by 4, is it the same as multiplying by 1/4? No?
All of it is just still under the
Yes.
radical, right?
Yes.
If this had been a 4 and said yes.
Got it.
But obviously for these problems, it's always going to be a 2.
Is the half now still under the radical too?
Yes, all of that is still under. So now I can rewrite this as negative square root of 2 plus root 3 over 4.
Oh, it's a 4 now. Yay.
Wait,
Now I'm going to split this into negative square root of 2 plus root 3 over the square root of 4. What is the square root of 4?
2.
So now I've got negative square root of 2 plus the square root of 3 over 2. And I'm done.
Question.
That's your answer.
Yes, because I cannot do anything else to it.
How did our square root start off negative?
Because of what a over 2 was.
Because it was in
Where
quadrant
this
2.
was.
Is this trig?
Yes.
Well, I thought we were gonna be done with trig. Are we never gonna be done?
After chapter 14, we're
How
done.
did we get a square root?
Will we have another test besides chapter 14 test?
Yes.
Okay, that's good.
What?
What's no, that's good.
But it'll be on like miscellaneous stuff from different chapters. It won't just be on one specific chapter.
Is that where we just skip from like the end of the book?
Ow. I poured a square root.
Because it was under a square root to begin with.
Okay, and that's root 2. Okay.
Alright. One more. Just example. The tangent of pi over 12. Alright, so for this one, I'm just going to tell you to make your life easier. If you've got radians, convert it to degrees. Okay, it'll just make it simpler. So pi over 12 is equal to, to convert it, 180 over pi. Pi's cancel, and that gives you 15 degrees. So I'm now dealing with the tangent of 15 degrees.
Right?
Yes. We don't know what 15 degrees is, so
Wait, really?
tangent of 1/2 of 30. Okay, so remember, 15 is a over 2, 30 is just a. So now, as far as with tangent, okay, I can pick really either one. It's not going to matter. I'm going to just pick the top one, so 1 minus cosine of a over sine of a. So 1 minus the cosine of 30 over the sine of 30. What's the cosine of 30?
Taylor.
Root 3 over 2. Sine of 30. 1/2. Okay, get a common denominator on top, which is going to give me what on top?
2. Right?
2
minus
minus the
root
root
3 over 2 over 2. The whole thing.
all over
right?
1/2.
Over 1/2.
Oh, yes. I am not feeling stupid.
Okay, now I'm dividing by a fraction, which means I do what?
Multiply by the reciprocal. So you
Multiply by the reciprocal, so 2 minus the square root of 3 over 2 times 2. 2's cancel, leave you with 2 minus the square root of 3.
Okay, that would make a little bit more sense, but
The tangent ones in this case are easier because
it's just hard.
they don't have square roots.
You know what? It's the first time I've ever liked tangent problems.
Wait, why isn't there radical?
Because it's not the formula.
Because it's not the formula. All right, that's sufficient for today. Tomorrow we'll actually look at problems out of the homework. So we'll call it a day there, and you can use the rest of class to work on the problems that are due at the end of class.